So let's take a look at the SI system. We're going to learn about some units and some conversions in this system of measurement. For starters, the SI system, the name, stands for a French phrase, which is Système International d'Unité, which literally means the International System of Units. It's more commonly known as the metric system. The metric system is a very old name that was used to describe this back a long time ago, as late as early as the 40s and 50s, as countries were switching over from whatever units they were using beforehand. It is a true system, unlike the units we have in this country today. And the reason it is because all units in the SI system are related by powers of 10. We don't have that in our current units that we use. What we use are called imperial units. And the imperial units are very old, and they're not really a real system. The units aren't really related in any intuitive way. For example, there are 12 inches in a foot. There are 3 feet in a yard, or 5,280 feet in a mile. There's no real relationship between volume ounces and weight ounces. There's two words, ounce, but they mean completely different things if we're using them for weight or for volume. 16 ounces in a pound, and then 2,000 pounds in a ton. There's really no sense to it all. So it's not really a system. Back in the 1970s, President Jimmy Carter at the time tried to get the United States to switch over from imperial units to the metric system. And it was a fairly involved effort. Back when I was fairly young, there were TV commercials. As a matter of fact, here's one now.
Take 10 America to learn the metric way. It's a simple system based on tens that you can start today. Efficient, more accurate, more universal too. It's good for our economy, our country, and for you. Now there's the meter. The meter. It's a little more than a yard. You think about it that way, it's really not so hard. The leader. The leader. Now please don't sell it short. It works out fine if you keep in mind it's a little more than a quart. The gram. The gram. About the weight of a single raisin. About the same as a paper clip. Now isn't that amazing? Celsius. Celsius. The temperature scale you see. A summer day's about 25. A cold day's -3.
Take 10 minutes to learn the metric way. Write Metric Education, P.O. Box 111, Washington, D.C. 20044.
Take 10.
This message has been brought to you as a public service by this station and the U.S. Office of Education.
In commerce, when you go buy something, the best we can do nowadays is dual labeling. So you know that you can find sometimes the metric equivalent on a packaging as well as the imperial units on there. 12 ounces, a 12-ounce can is 355 milliliters of soda. Okay, that sort of thing. But there's some confusion here, especially when people from this country travel to like the EU, for example, or Great Britain, or any of those places where they're using the SI system. There can be a lot of confusion in figuring out what are they actually telling me. One of the most common ones is in temperature. If they tell you it's 25 degrees outside, in this country, we know that we need to bundle up. Well, actually, no, we're from Wisconsin, so we probably just wear maybe a light sweater. But if they say 25 degrees in the EU, well, that's pretty hot. That's a warm enough day you could probably wear shorts and a t-shirt. So there is a lot of confusion when we travel and when we try to justify one for the other. So there are some common SI units that you should be aware of. We've used some of them already. Actually, we've used all of them already. We just want to become familiar with them. So for mass, the standard SI unit is the gram. It's represented by a little g. For volume, it's the cubic meter or the liter. Now, you haven't used either of those yet because we've been using smaller volumes. A cubic meter would be a cube, 1 meter on a side. That's big. That's a lot of volume. But a cubic meter and a liter, those aren't equivalent measurements. We've been using things like cubic centimeters and milliliters, and those are related a little bit more closely than cubic meter and liter. But these are just ways that we can measure volume. Length is measured in meters. We've used that already. We've used centimeters, or we've used perhaps millimeters. And temperature. Temperature is measured in the Celsius degree, sometimes called centigrade degree. We don't use Fahrenheit in science at all. Fahrenheit was developed to work with the weather. It's not really sufficient for most science work. So you're not going to find too many scientists around the world who think very highly of the Fahrenheit system. It's used for weather in this country, and that's about it. What we need to become familiar with, though, is the way the SI system works. And it works by using some prefixes. And each of the prefixes has a certain multiplied value that multiplies by the base unit, the gram, the liter, the meter, or the cubic meter. And the prefix helps us to figure out the relationships between the unit we're working in and the base unit. So the prefixes that we'll be using most commonly in this class are kilo, which means 1,000 times bigger. So a kilogram is 1,000 grams. A kilometer is 1,000 meters. Kilometer. Deci, which is 1/10, and comes from the Latin word for 10. Deci is 1/10 of the base unit. So a decigram is 1/10 of a gram. A decimeter is 1/10 of a meter. Centi, which means 1/100th of the base unit, and milli, which means 1/1000th. You can think of them in terms of fractions like that, or you can think of them in terms of powers of 10, and it's sometimes a little bit more handy to think of them in powers of 10. 10 to the third power is 1,000, so kilo is 10 to the third times the base unit. Deci is 10 to the minus 1. 1 over 10 would be written as 10 to the minus 1. 1 over 100 is 1 over 10 squared, or 10 to the minus 2. 1 over 1,000 is 10 to the minus 3, and so on. Alternatively, you could think of them on a number line, like this one here, where the base unit, we sort of start there, and then each of these spaces is a power of 10. So if we go up 3 spaces bigger than the base unit, in other words, to the right, it becomes kilo. And if we go down 1 space, it becomes deci, and 2 spaces becomes centi, and 3 spaces becomes milli. Whatever way you're comfortable in thinking about the multiplier is fine, as long as you know what each of these prefixes mean, because they're going to help us when it's time to make conversions in the SI system. So the nice thing about everything being based on a power of 10 is that if you want to make a conversion from one unit to another, you don't really have to do any math. You just have to move the decimal point. In our imperial units, if I tell you, you have 1,512 feet, how many miles is that? Well, it's not quite a mile, it's a fraction of a mile, and we have to figure out, well, what do? I have to divide by 5,280, and there's math involved. That's no fun. So if I want to figure out, for example, how many centimeters there are in 1.25 meters, it's easy. It's just 125 centimeters. I just move the decimal point 2 places. Now we're going to practice some of these, but what you need to know to do this, to do it well, are 2 things. The first thing you need to know is which direction to move the decimal point as you're converting. And the direction that you move the decimal point in is dependent on whether or not you're going from a smaller measurement to a larger measurement, or a larger measurement to a smaller measurement. If you're going from a large measurement to a small, move the decimal point to the right. Moving the decimal point to the right makes the number bigger, but that's what's going to happen. If you have like meters, which are very big, and you're going to centimeters, there's going to be a lot of centimeters in a smaller number of meters. The number has got to get bigger, so we move it to the right. If you're going the other way, small measurement to a large measurement, move the decimal point to the left. So that's the first thing you have to figure out. Which direction are you moving the decimal point? The second thing you have to figure out is how many spaces to move the decimal point. And that's based on the powers of 10 that we talked about. I find it useful to use the number line because you can just count spaces, and the number of spaces is equal to the number of places to move the decimal point. So let's try a few examples. I'll do a couple, and then I'll have you try a couple, and see how you do. So let's make the conversion 2.50 meters to decimeters. How many decimeters is that? All right, so the 2 questions we have to ask ourselves first are, which direction do I move the decimal point? All right, so I need to look at this. There's meters, there's decimeters. meters is bigger than decimeters. So I'm going from a large to a small measurement. So when I go from large to small, that means that I'm going to be moving the decimal point to the right. So there's my first answer. Second question that I have to ask myself is how many spaces? So in order to do this, until you're used to it, use your number line. If you look at the number line, we'll see that deci is one space away from the base unit, meters. So that means I'm going to move the decimal point one space. So we take the number 2.50 meters. We move the decimal point one space to the right, and we get 25.0 decimeters. And there's our answer. Pretty simple. Let's take another one. Now this time we'll go the other way. So we'll do 272.31 centimeters, and we're going to convert that into kilometers, kilometers. Okay? So again, let's ask the questions. First question is, which direction do I have to move the decimal point? And again, we're going to look at the units. I'm going from centimeters to kilometers. Smaller, that's bigger. Small to large. Small to large means I move the decimal point to the left. So there's my first answer. Second question is how many spaces again? Okay, so now I'm not using the number line here. I'm not using the base unit. I'm going to have to look at my number line and count my spaces from between centi and kilo. So if I look at kilo, kilo is way over here on the right, and centi's back here on the left. Kilo, if we count backwards or forwards, it doesn't matter. We just need to know the total number of spaces. We've got 1, 2, 3 to get to the base unit, and then another 2 to get down to centi. So that's 5 spaces. So we're going to move the decimal point 5 spaces to the left. So that's here. There's 1, there's 2, there's 3, 4, 5. Now I've got to put some place-holding zeros in that space to account for the extra decimal places that I just moved. So 272.31 centimeters is equal to, I'm going to put 2 zeros, so decimal point, then 2 zeros, and then 272.31 kilometers. It's a large number of centimeters, but a very small number is not even close to 1 kilometer yet, and that's because a centimeter is so much smaller. So there's your answer. Okay? You ready to try one? All right. Try this one. 45.21 millimeters, and I want you to convert that into centimeters. Okay? Stop the video, try it out, and then come back when you're done and see how you did. You done? All right, so let's take a look. What are our questions? First question is, which direction do I move the decimal point in? So I'm going to look at my 2 measurements, and I'm going to say, okay, I'm going from milli to centi. Well, millimeters is smaller than centimeters, so I'm going from small to large. When I go from small to large, that means I'm moving it to the left. That's the first question. Second question is, how many spaces? So now I'm going to look at my number line again, and I'm going to see, okay, centi is here, milli is here. They're 1 space apart from each other. So that's just 1 space. That means I'm going to take my decimal point, I'm going to move it just between the 4 and the 5 there. So that means 45.21 millimeters is equal to 4.521 centimeters. And there's your answer. Is that what you got? If it is, seems like you're doing it. You'll get some practice. If not, watch the video again. Ask questions in class. We'll work on it. You'll get it.